Okay, this is lesson 3.3, slopes of lines. So you might want to think, oh my gosh, slopes, we're going skiing. You can think of it that way, but we're talking about the algebraic kind of slopes we're looking at. Definition of slope. It depends on what you're looking at. It depends on if you're looking at a graph, a table, or an equation. If you are looking at a graph, the most common answer to find the slope is rise over run. Okay, and I'll show you that in a little bit. Table, I usually say change in y because your rise is up and down, which is your y-axis, so change in y. Run is left and right, which is your x-axis, so change in y over change in x. There's also a very famous formula that you might recall from Algebra 1, y2 minus y1 over x2 minus x1. All right, and then an equation, we have several different types of equations, but the only one I'm going to focus on today is slope-intercept form. We'll talk about the others in the next lesson. It looks like this. This should look familiar. It doesn't have to be an M or a B, but this right here is your slope. Okay, and you could write it the other way. You could have B plus mx, and this would be considered your slope. Okay, it's whatever is next to the x. Vertical lines go up and down like this. They always have a slope that is undefined. Don't try to use a different word or say there's no slope. I want the word undefined and nothing else. Horizontal lines have a slope of 0. Okay, so you can have a slope of 1, 2, 3, 4, 5, or 1.1 or 1.2, but when you get down to 0, you have a horizontal line. So horizontal lines have slopes of zeros. All right, examples 2 and 3. We're going to go ahead and put these on the graph and take a look at what happens. So we're going to have a quick review of graphing at the same time. This is your slope. That's M. Your B value is your y-intercept. Oh yeah, this stuff. Your y-intercept is -4. Your slope is 3. Remember how we said rise over run? So from this dot, you will rise 3 and then run 1, put a dot. Rise 3, run 1, put a dot. Rise 3, run 1, put a dot. And usually I try to put some down here as well so we can kind of see the pattern the whole way through. And then, when you're all done with that, you go ahead and make your line. Oh, isn't that pretty? Okay, now we're going to graph the next one. Same process. Start with my y-intercept. Okay, 1. That's 1 on the y-axis, the intercept on the y-axis. And then you have a slope of 3. So again, same thing. Rise 3, run 1, put a dot. Rise 3, run 1, put a dot. So on and so forth. Keep going, maybe even in the other direction. And then we take and make our line. You know what's crazy about this? It sure looks to me like those lines are parallel. No. Yes, they are parallel. And that's just crazy considering that we had slope of 3 and a slope of 3 and they ended up being parallel lines. I wonder if that's a coincidence. All right, let's look at this second set here. I've got 1/3 x minus 4. So my y-intercept is -4. Okay. And I have a slope of 1/3. That means from this point, I'm going to rise 1, and then I'm going to run 3. Rise 1, run 3. Rise 1, run 3. I'm going to go a couple the other direction. It's actually down 1, back 3, -1, -3, which is the same as 1/3. And then I go ahead and make my line. Oh, that was a horrible line. Let me try that again. There, that's better. Now I'm going to graph the other line of this pair. I've got a y-intercept of 2, and I've got a slope of -3. So I put my y-intercept at 2, and I have a slope of -3. So I will rise -3, which means I go down 3 units, and then I run +1. If I go -3 over -1, I need to put a +3, and I need a -3. Okay, and then also just double check, is my slope going downhill? Because it's a negative slope, I should be looking at a downhill situation here. And yep, I got it. Now, if you're graphing this on your own, you should see that these lines meet and form a beautiful right angle. Now let's look at our slopes again. One of them is 1/3, and the other slope is -3. I wonder if there's some kind of a connection there, kind of like the equivalent slopes. Maybe there's something about perpendicular slopes. All right, let's just try this next one here. I've got no y-intercept, but I have a slope of -3/4. So I'm going to start at 0, and I'm going to rise -3, and then I'm going to run 4. Rise -3, and then I'm going to run 4. And I'm going to go the opposite direction in the other way. And then I'm going to make my line. Boy, I need to work on line making, don't I? Let me start right on the dot, because that'll help a lot. Oh, that rhymes. Let me start on the dot, because that'll help a lot. Okay, there's my first line. Now, let me try this 4/3 x, which means I also have a y-intercept of 0. And then I rise 4, and then I run 3. And I put down a mark. I rise 4, and I run 3. Okay, and I do the same thing down this way, and then I make the line. Okay. Oh, guess what? Those are perpendicular. There's a beautiful right angle in there again. This comes together to form a right angle. If you're doing that on your own paper, then you would see that. Oh, cool. Way cool. So once again, there's got to be some relationship between -3/4 and 4/3 that somehow is going to end up with perpendicular lines. On to the next set. Graph y equals -3. In other words, my y-intercept is -3, and I have a slope of 0. That's basically what that's saying. So I have a y-intercept of -3, the slope is 0. So I rise 0, but I can run 1. Rise 0, run 1. Oh yeah, this is a horizontal line. The equations of horizontal lines are y equals, and then I have a number after it. Another trick, or quick trick on this, is to go to -3 on the y-axis and make your line. Okay, now I'm going to graph x equals 2. Okay, so that means I go on the x-axis. I need a different color here. I'm going to make a point at 2, and basically my slope is undefined. And that gives me a line like this. Okay, and then I need to go ahead and make a line through there. I think I can make that even a nice funky green. Nope, I guess not. There's my line through there. And what's interesting is that we have, again, a right angle. Okay, and we'll talk about this a little bit in class as well, what the slopes are when you have a vertical line and a horizontal line. Basically, 0 and undefined are reciprocals, in a way, of each other. All right, parallel slopes. Let's get something you can all see. The slopes are the same, or they're equal, equivalent, identical, things like that. Perpendicular slopes are opposite reciprocals. Okay, so while parallel slopes, you got a slope of 2, then the other line would have a slope of 2. But with perpendicular, I call them opposite reciprocals. Basically, if you multiply them by each of the, if I multiply my slopes, you're going to get -1. Usually we don't try to do that every time. I'm going to give you a slope, 3/7. The perpendicular slope to 3/7 would be negative. That's the opposite. And then the reciprocal would be 7/3. Okay, if I give you a slope of 4/9, let's do -4/9. The perpendicular slope would then have to be opposite, which would make it positive. You don't have to always write that. And then the reciprocal of this would be 9/4. Let's take a number like 5. The reciprocal of 5, think about it, it's actually 5/1. So perpendicular, we change the sign to negative, and then you flip 5/1 becomes 1/5. So 5 and -1/5 are opposite reciprocals, and if you were to graph a line with a slope of 5 and then graph another one with a slope of -1/5, la 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 la, perpendicular. Okay, here we go. Example 6. You have to find the slope of each line. So I've got a dot down here, a dot up here, rise. 1, 2, 3, 4, 5, 6, 7, 8. So I have a rise of 8, and I have a run of -2. So I have a slope of -4. Then graph a parallel line. Okay, and I'm going to pick any point on here, and basically I will do the same thing. I will rise -4, and then I will run 1. Okay, and then if I go rise +4, run -1, I will end up with my parallel line. Oops. Okay, then graph the perpendicular line. Okay, so if I'm going to do perpendicular, then my slope would have to be positive 1/4. Okay, if that's going to be the case, then I'm going to start right here again, and then I would have to rise +1, run 4. Okay, I'm running out of graph, go the other way, come through like this. And of course, if you're just drawing this like this, oh yeah, they're perpendicular. Okay, I am probably going to do just this other one. Let's go to C, and if you really need me to show you the other two, we can do that in class, but I think we're going to be okay with 2 examples here. From this dot to this dot, and I'm looking to see if there's a nice perfect little corner in between, but there's not. 1, 2, 3, 4, 5, 6, 7. So I'm rising 7. I'm going to run 1, 2, 3, 4, 5, 6, 7, 8. Ooh, 7 eighths. So if I want to make something that is parallel to this, I'm going to put a dot right here, and I can rise 7. 1, 2, 3, 4, 5, 6. I'm going to kind of judge 7, and then I'm going to go over 8. 1, 2, 3, 4, 5, 6. I'm kind of off the graph a little bit. All right? But if I were to connect these, and if I could do it perfectly, I would find out those lines are parallel. If I wanted to make a line that was perpendicular, then I would have to have a slope of -8/7. Okay, so I'm going to just, let's just pick right here. -8, 1, 2, 3, 4, 5, 6, 7, 8, and then run 7. 1, 2, 3, 4, 5, 6, 7. Let's make the corner of the graph. If I make the line, oh my gosh, the original line here and the red line, perpendicular. And then there was a rule in the other lesson about if it's perpendicular to one line, guess what it is, and this line is parallel to this one? Ooh, it's going to be perpendicular as well. That's just a neat little tidbit. I think that'll be plenty for examples on that. Example 7. Determine whether line FG and line HJ are parallel, perpendicular, or neither. So in order to know that, I need to use the slope. And you notice I have no graph paper here. I don't really want us to graph out every single one of these. So I'm going to do this the first time. We have to use change in y over change in x, or y2 minus y1 over x2 minus x1. I oftentimes will set it up in a table, 1, -3, -2, -1. What's the change from -3 to -1? I have to add 2. Okay, what's the change from 1 to -2? I have to subtract 3. So the change in y value is 2. The change in the x value is -3. So I'm getting a slope of -2/3. For those of you in Algebra 1 that were very adamant about the formula, some people just love formulas, then you would do this. You got x and y, these are your 1s because they're first, these are my 2s because they're second. I can go y2, which is -1, minus, and then my y1 value is -3. And then I do x2, which is -2, and then -1. And then I figure this out, and remember that horrible thing that I do, I make a big plus out of this. So it's -1 plus 3, so I have 2. And then -2 minus 1 is -3. Oh my gosh, it's the same answer either way if we do it right. So the slope of line FG is -2/3. Now I have to compare that to the other points. Okay, I don't know that I'm going to show you both ways. I'm just going to mix it up a little bit. 3 minus 0, 6 minus 5. 3 over 1 is 3. So the other has a slope of 3. Is there a relationship? Are they going to be parallel? No, the slopes are not the same. Are they going to be perpendicular? Meaning, are they opposite reciprocals? And no. So this is going to be a case where they're neither. They're just like two random lines that just ran into each other. Nothing special about them. Example 8. Kind of the similar kind of setup. Let's take a peek and see. This time I'm going to do this way. 4, 2, 6, -3. The change from 2 to -3 is -5. The change from 4 to 6 is 2. So the slope on this one is -5/2. Okay, I'm going to go the formula way to find the slope on this. 10 minus 5 over -3 minus -1. Okay, once again, do the horrible plus thing, and I've got a 5 over -2. No way! 5 over -2 is the same as -5 over 2. They end up being -2.5 if you put them into your calculator. If they're exactly the same, that means they are parallel lines. Example number 9. Determine whether these are parallel, perpendicular, or neither. All right, so AB, I'm going to use the traditional method, 5 minus -1. Oh, look what I did, minus negative, I just changed it to a plus. 4 minus -2, which gives me 6 over 6, which gives me a slope of 1. So I have a slope of 1 over here. And now I'm going to go back to my lovely table when I do 6, 1, and 9, -2. To get from 1 to -2, think of the number line, I go down 3. To go from 6 to 9, I have to add 3. So I have -3 over 3. That gives me -1. Are these opposite reciprocals? Yeah. If you think about it, if I take 1 and I change the sign, and then I find the reciprocal, I'm going to get -1. So these just so happen to be perpendicular. And example 10. I can give you all kinds of situations with this, but we're just going to kind of do one, and you can apply what you know to the rest of the problems that are similar to this. Sorry for the crazy mess up there, but graph the line that contains 5, 1. So I'm going to put the point right here. That means I have to make a line that goes through that particular point, and it's parallel to MN, with M having a point at -2,4 and N having a point at 2,1. So in other words, I have to find the slope, okay, and then I have to make sure that my line will be parallel to that. So I'm going to go, just because this is my favorite way, from 4 to 1, I go down 3. From -2 to 2, I go up 4. So my slope is -3/4, and I want it to be parallel. So if it's going to be parallel, I will, from this point, rise -3, run 4. I better go the other way. Rise 3, run -4. Rise 3, run -4. And then make my line. Once again, I've got to make better lines. Start right here. Okay, that works a lot better. Now, here's a quick check. You can kind of say you're done here, but I'm just going to put in, just because I'm a little curious, -2, 4 is right here, and I've got a point 2, 1. And if I were to draw a line through those 2 points, does it turn out that they are parallel lines? Yeah. Okay, so there's kind of a double check with that. Moving on. Oh, we're done.